Hello Nozomi, good morning.
Oh, hello, Aruni. Morning.
Okay, we still waiting for our students. Maybe they still want to join in our Zoom.
Okay.
Thank you, Nozomi.
Yeah, you're welcome. Thank you for thank you for the invitation.
Untuk yang host mungkin perlu di-approve. Udah banyak yang belum join.
Iya.
Ayo Rosi.
Sesi.
Cek 1, 2.
Kali. Tes, tes. Agak keras sedikit. Tes, tes. Coba nyalain terus. Tes, tes. Masuk. Masuk, masuk.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera untuk kita semua. Om Swastiastu, salam budaya, dan salam kebajikan. Good morning everyone and warm greeting to all of us.
Halo teman-teman, apa kabarnya? Semoga semua dalam keadaan sehat dan semangat selama mengikuti acara hari ini secara daring melalui Zoom.
And welcome to today's guest lecture with Magic Pot Inc., organized by our study program. And this is a great opportunity for all of us to learn directly from technology practitioners.
Especially on the topic of AI-based testing automation, which will be delivered by Nozomi Ito-san, CEO of Magipot Inc. from Japan.
Perkenalkan, saya Yesa Putri.
Dan saya Alif Gayo.
Kami berdua akan memandu acara hari ini sebagai Master of Ceremony.
To officially begin our event, let us first listen to the opening remarks from the head study of program. Kepada Dr. Dewi Rahmawati, Eskom, selaku Ketua Program Studi, kami persilakan untuk memberikan sambutannya.
Yeah. Thank you, Alif and Yesa. Yeah. Good morning, everyone. Especially Nozomi Ito-san and Ibu Animu Arifa. Yeah. To our esteemed speakers, Nozomi Ito-san, CEO of Magic Pot, and my dear students, it's genuine pleasure to welcome you today in Stadium General, focusing on incredibly timely and transformative topics, artificial intelligence in automation testing. Hello, welcome, Nozomi Ito-san. Yeah, we are just as excited to have you at Magic Pot team to present to our students. We're sure it will be incredibly beneficial. Our program study is dedicated to preparing students for the challenges and opportunities of tomorrow's industry. This event truly reflects that commitment. We are excited for the student to gain fresh insights and inspiration from our expert speaker. And my sincere hope is that through today's Studium Generals, all students will learn even more, gaining new perspective and feeling inspired to continue their self-development. Let's make the most of this invaluable learning opportunity. Thank you and enjoy the Studium Generals. Thank you.
Terima kasih kepada Bu Dewi Rahmawati atas sambutannya yang sangat menginspirasi. But before we proceed to the main session, allow us to briefly introduce our speaker for today.
He is Nozomi Ito, CEO of Magipot Inc., a company specialized in developing AI-powered test automation platforms for web and mobile applications.
Mr. Ito is also actively involved in technology innovation and international collaboration. And today we are honored to have him share his knowledge and experience directly with us. And first of all, Mr. Nozomi Ito, thank you very much for joining us today. And even though we are connected only virtually from different countries, it is truly pleasure to have you here.
Okay, thank you. Thank you so much. Thank you for great introduction on me. So, is it okay to start the presentation? No?
And we really appreciate your time to share your expertise with our student and participant, and especially in this growing field of AI-based automation testing. We are very excited to hear your insight, and hopefully, even though we are miles apart, the learning spirit remain strong throughout this online session.
Yes, hopefully, even though we are miles apart, the learning spirit remains strong throughout this online session.
And once again, thank you very much, Ito-san. Now, without further ado, let us begin today's lecture, and the screen and time are yours.
Okay, thank you. Can I share the screen? Oh, I can't share. Maybe I don't have necessary permission.
Yes, you could already share your screen.
I haven't shared yet, so I need permission by organizer maybe.
You already have the permission, Mr. Nozomi.
Oh, really?
Yes.
Sorry, but it seems I'm not not co-host. And I can't start screen sharing, sorry. Okay. Okay, I can do now. Okay, sorry for small trouble. And thank you everyone for great introduction for me and invitation for me. Good morning, everyone. I'm Nozomi from Magicpot. Today I'm speaking from Japan, where the time is 2 hours ahead of Indonesia. So now it is already around noon. Last year, I visited Indonesia and met Arnie, and thanks to this connection, I have the chance to speak here today. It is truly an honor, and I have been looking forward to this moment. I run a company focused on test automation using AI, and today I will speak about test automation tools, and how we use AI. Sorry. Okay, this is today's talk agenda. After the short introduction, I will talk about what software testing and test automation are. And next, I will introduce MagicPot and its use of AI. And finally, I'll explore the future of software testing with AI. Okay, first, let me introduce myself briefly. So, I'm Nozomito. I'm the CEO and the founder and still an engineer of MagicPot. MagicPot is a Japanese company providing a test automation cloud service, which has been adopted by over 500 companies across Japan. I also organize the Japan Selenium user community, which focuses on the well-known open source test automation tool Selenium. I'm also the author of Japanese book titled Selenium Practical Guide. So I have many years of experience in startup business, software development, and software testing. Next, let me present our product, MagicPot. It is a no-code test automation tool that enables users to automate software testing without requiring coding skills. It supports testing for both web and mobile applications. And it offers a free plan and a paid plan with more powerful features. At the end of my self-introduction, I will share my experience from my past trips to Indonesia. Last year, several members of MagicPot and I traveled to Jakarta, Bandung, and Surabaya. We held hands-on workshops there where participants could try MagicPot directly. The attendees were engineers and testers from various tech companies in Indonesia. Okay, and during the workshop, we discussed the test automation and MagicPot. It was a valuable moment for me. Okay, now let's move forward with the main topic. First of all, I will provide an introduction to software testing and test automation. Maybe you have written a computer program in the classes of the university, and after the program was completed, maybe you have checked if it worked as expected. If it is just a toy program, the check won't be so difficult. You just launch the program, click several buttons, input several values, and then you can confirm it works as expected. It may not work in some situations, but you only have to fix the problems when you encounter actually them, because the user of the toy program is only you. But if the software is commercial software and it has many users, the situation is different. You need to check its behavior more carefully, check many input patterns, check the UI is not broken, check behaviors on various devices, and check its performance and security. These checks are called testing. And testing in the real world product is very, very, very complicated. Sorry. If sufficient testing is not conducted and the software contains bugs, it could lead to customer dissatisfaction, financial damages to the company, a security incident, or even harm to humans. So testing is very important in a real-world development project. Actually, it is said that around a third of the time and efforts of a development team are spent on testing. When I learned computer science at the university, I couldn't imagine that. But after graduating from the university and joining a software company, I soon realized that. In real-world product development, coding is only one part of software development. You need to discuss with customers or the marketing team, decide design, read the source code written by other members, review the code, and test the program. They require much more time than just writing code. And despite that testing is an important work of engineers, surprisingly, it is still largely done by manual work. In large software companies, there were usually people engaging in testing. They are called testers or quality assurance QA. Some QAs automate these testing activities, but still many tests are done manually all over the world. The testing process is like that. First, QAs or testers list test patterns on the spreadsheet or test case management tools. Then conduct all test patterns manually and write test result to the spreadsheet or test management tool. If the company does not have testers or QAs, developers have the responsibility for the quality and testing. So actually, every developer needs to learn quality and testing. 10 years ago, we could maintain the quality of software by manual testing. Because the new version of the software was not shipped so frequently. The release was once or twice a year, and testers only needed to check its quality before the release of the new version. The manual test could require several weeks or even months, and it was a heavy burden, but the test team could manage it manually. But now, after 10 years, the situation has changed. More and more companies adopt agile development, and the software is released every month, every week, or even every day. So repetitive manual test happens every month, week, or day. As an engineer, so can you tolerate that? I can't. It is really inefficient and boring. That is why more and more companies automate their testing activities. Automation testing is very important in today's development projects, and this trend will continue even in the era of generative AI. Automated test can be classified into three types. That is unit tests, integration tests, and end-to-end tests. Unit tests are used to check the behavior of single component or a program. Integration tests are used to check the behavior of integrated multiple components of a program. API tests are the most common typical example. End-to-end tests are used to check the behavior of the whole system. UI tests are the most typical example. And the best proportion of each type is like this chart. We should use unit tests the most, and end-to-end tests should be used only when other types of tests cannot cover the cases. This chart is called the testing pyramid. Recently, some people have proposed other shapes, like testing trophy or testing hourglass. But I think the testing pyramid is still the most common shape. Next, I will explain three types of test automation tools: code tools, low-code tools, and no-code tools. If you automate tests with a code tool, you need to write test code, and it requires coding skills. On the other hand, with low-code or no-code tools, you can automate tests without coding. Low-code tools still require coding skills, but their users can automate many tests without coding skills. You may already know the names of various test automation tools. I put some well-known tools on the matrix of test types and tool types. The first row is unit testing tools. Unit tests are tightly associated with the application code, and I believe all unit testing tools are classified as code-based tools. And the second row is integration testing tools. And they are usually API testing tools. We can automate many API tests without understanding the application code and writing test code. But some tests still need code knowledge, and therefore API testing tools are code-based or low-code-based tools. The last row is end-to-end testing tools. They are usually UI testing tools, and they can be code, low-code, or no-code tools. Open source tools such as Selenium, Playwright, and Cypress usually require coding skills. Other well-known UI test automation tools, Catalan Studio, Lanorex, make test automation easier, but it is still difficult to fully utilize them without coding skills. So I classified them as low-code tools. On the other hand, MagicPot is a completely no-code tool, and the user can use it without coding skills. I will show several examples of test automation. This is the first sample code of JUnit, a code-based unit testing tool for Java. Let's say you write a simple program to add two integers, the function add. If you want to check this program's behavior, you need to write a test program like this with JUnit. In the test program, you call the add method with the parameters 1 and 1. And by assert equals method, assert or confirm that the result is 2. This is how a unit test functions. Another example is the end-to-end tests. This is a sample code of the well-known browser end-to-end testing tool Selenium. In a Selenium script, we describe how Selenium interacts with the browser. In this script, we instruct Selenium to go to the Google URL, find the search area, and input the text test automation, and then click the Google, then Go button. After clicking Go button, we expect that page transition happens, and the page title becomes search result. So in the last line, we confirm the page title is search result. This is how an end-to-end test functions. Basically, an end-to-end test manipulates the application screen automatically and checks the behavior of the application through the user interface. Next, I will share some prevalent misconceptions surrounding test automation. Many engineers tend to have these ideas, but we must avoid them carefully. The first misconception is that we don't need to do anything once tests are automated. Actually, test scripts need to be maintained each time the test target application is updated. And the cost of continuous maintenance is not ignorable at all. Also, you may think everything can be automated, but actually not. One major mistake is automating everything as end-to-end tests or UI tests. Actually, UI tests are very slow and their maintenance cost is very high. You need to use unit tests proactively according to the test pyramid best practice. And the final misconception is that automation is just for cutting cost. It sounds correct, but actually not. The reality is that the cost of maintaining test script is so large that it sometimes offsets the benefit of reducing manual testing. That sounds weird. If automation does not reduce cost, why do we automate tests? This is the answer. The real goal of test automation should not be cost reduction. Instead, it should be improving productivity and velocity. If you automate a test, you can run tests every day. Then, if a developer changes the product code a bit, and the change contains a bug, the automated test can detect the problem very quickly. This increases the velocity of the development team. And since the developer can notice and fix the problem earlier, the productivity of the development team is also improved. The same happens with the QA team. The test team can detect bugs earlier, and they can reduce the risk of a delayed schedule due to the bug. They are the real benefit of test automation. Even if maintenance cost is required, the benefit of repetitive testing and faster feedback is very large in today's business environment. So far, I explained the overview of software testing and test automation. Next, I will explain what our no-code test automation tool, MagicPot, is and how it works. First, let's check how MagicPot works in this video. Actually, let me show the YouTube screen. Okay. Test creation of MagicPot is 3 steps, so it is very simple. Sorry. So 3 steps. 3 steps. Launch browser, select element, and create steps, and then click the Run button. First, launch browser, and specify test target URL. Then, test target web page is launched inside Cloud Browser on the test edit page. And next, click the select button, and then MagicPot detect elements, and you can choose elements from the detection result. And after filling in input values, the simple test case is created. By running Run button, test is executed on the cloud device, cloud browser, like this. That's it. So this is very simple process. You can very easily create a test and execute it. Okay, let's go back to the slide. Sorry. Sorry. Please wait a bit. Sorry. Let me tweak the display setting a bit. Okay, it must be okay now. Sorry, okay, let's resume the presentation. Okay, this is how MagicPot works. MagicPot is different from traditional test automation tools in many aspects. For example, a traditional test automation tool requires coding skills. But since MagicPot is a no-code test automation tool, even testers without coding knowledge can use it. Also, installation of a test automation tool tend to be very troublesome, especially when the tool is for mobile app testing. But since MagicPot is code-based service, no installation or setup is necessary. And its setup process is quite simple. And finally, as I already mentioned, test automation scripts need to be updated every time the page structure of the website or mobile app is changed. This maintenance cost is heavy burden on users. But if you use MagicPot, if such maintenance is required, the AI identifies the page change, and according to the change, it updates the test script so that it doesn't fail. This AI feature largely reduces the cost of maintenance. Next, let's proceed with the internal mechanism of MagicPot. First, I will talk about the mechanism of test creation. When you create a test, as you saw in the demo video, first, user clicks select button to analyze the screen of the application under test. The analysis process gets the screenshot and the internal UI3 or HTML of the screen and uploads them to the server. For each element, it calculates the human readable caption or name, and locators or selectors to identify element. The human readable caption is only for human readability, and you can update it manually later. On the other hand, the locators are the system information, and they are used to specify the target UI element on the screen. So they play a very important role in test automation. Once the UI scan has been completed, you can select any elements on the screen. And by choosing one element and dragging and drop it to the test edit area, a command is added depending on the type of dropped item. If you drop a button, then click command is generated. If you drop an input area, then the input command is added. By repeating this action, you can create one test scenario. The test script is internally in JSON format like this image, and it is stored in the database on the server. Next, let's take a look at the test execution flow. When you click the test run button, the test script in JSON format is retrieved from the database, and it is converted to Selenium or Appium script in TypeScript. This script can be run with Node.js and Mocha. After the conversion, the script is downloaded to the device, and it is executed with Mocha. After the test run, the result is uploaded to the database. This is how test execution works. By the way, MagicPot has two types of execution methods: cloud test and local test. And the system flow of each method is a bit different. For the cloud test, a test script is downloaded to the browser or device on the MagicPot cloud, and the test is executed on the cloud. On the other hand, for the local test, a test script is downloaded to the browser or device on the user's local machine, and the test is executed on the user's machine. To download and run test script on the user's machine, the user needs to install the MagicPot desktop client on their machine in advance. Okay, I already explained the software testing and about MagicPot. Next, I will discuss today's main topic, how MagicPot leverages AI. So MagicPot uses AI for various purposes. And today, I've highlighted 4 key use cases: human readable UI element captions, self-healing, summarization of text script, and MagicPot MCP server. Let's dive into each of these topics one by one. The first one is calculation of human readable caption of UI elements. As I already explained, each UI element has a human readable caption in addition to its locator. The human readable caption is calculated by our AI logic based on OCR or optical character recognition and object detection result from the image, and HTML information or UI3 information. Since the caption is only for human readability, you can fix it manually, even if it is wrong. The second AI use is self-healing. This is the feature to maintain test cases automatically by AI. When a test can't find a UI element due to a change in the application's page structure, MagicPot AI modifies the test case so that it doesn't fail as long as possible. In this example, the register button of the page is changed to the sign up button, but the test tapping the register button does not fail because MagicPot's AI updates the occurrence of the register button in the test script to the sign up button. The third and fourth examples are the features that leverage generative AI. I believe you already know what generative AI is. ChatGPT is the most famous generative AI across the world. By the way, MagicPot uses ChatGPT internally. One example of the use of generative AI is the summarization of test scripts. Test scripts of MagicPot are human readable, but even so, it is not easy to understand what a large test script actually does, especially if the script is created by other members in the development project. MagicPot summarizes each test script automatically by generative AI so that users can easily understand what each test script does. And the final example is the MagicPot MCP server. Do you know what the MCP server is? MCP means Model Context Protocol. It is the general protocol to connect the generative AI and external services, such as Zoom, Slack, GitHub, Notion, and of course, MagicPot. If a user uses some coding AI agents, such as Klein, Cursor, Claude, have you already tried some of them? By using MagicPot MCP server, these coding AI agents understand the MagicPot and can do various actions using MagicPot. Also, you can ask various questions related to MagicPot to the AI agent. Okay, we have example. Sorry. Oh, it is not easy to stop. Okay, I will demonstrate the example of MCP server. This is an example using Claude Code. First, tell AI like this. Sorry, it may be a bit quick. So like this, upload application to MagicPot and run test. Then Claude understands this instruction. So instruction and recognize it, and then start a magic pot test. So it start test by calling magic pot web API. So, and after it, user visit magic pot test screen, and the user can confirm test is already started. So by asking, sorry, I'm not get used to manipulating this tool. So by specifying instruction by natural language, Claude Code can do magic pot test execution. So this is how magic pot MCP works. I already installed magic pot MCP to Claude Code, and that is why Claude Code understands the magic pot command. Okay, and this is the internal structure of the magic pot MCP server. If a user tells the AI agent, for example, start batch run, the AI first gets the list of tools that magic pot MCP provides. And based on the list, the AI decides what to do, and by using this tool, call the magic pot MCP server. Then the magic pot MCP server calls the web API of the magic pot and returns its response to the agent. This is the internal mechanism of communication between an AI agent and the magic pot MCP server. By using MCP servers, we can extend the capability of an AI agent drastically. Finally, I will discuss my perspective of the future of the AI agent and software testing. I will discuss the two topics: our future plans for AI agent and generative AI, and the future of software testing. First, I will introduce the plan of magic pot for AI agent and generative AI. I have already introduced several features leveraging several generative AI, but we have a plan to release more and more AI features this and next year. I will introduce some of our future plan. The first planned feature is creating and editing test cases in natural language. As you can see in these images, by telling Magic Pot what test to create by natural language to Magic Pot, the AI will generate a no-code test script automatically. Actually, its prototype is already ready, and the first version will be released before long. This feature will be available both for web and mobile app testing. In the first version, its capability will still be limited. And if we try to use it for a business application, it frequently won't work as expected. But generative AI will continue to become more and more intelligent. And as it becomes more intelligent, this feature will also be more intelligent and more useful. By the way, if strange steps are generated, users can easily understand the issue and fix it, because MagicPot is a no-code platform and the test script is easy to understand and maintain for everyone. So I have a sample video, so I'd like to demonstrate it. This is a simple example of test creation. This is still a prototype, and the user interface and the user experience are very ad hoc. But I think you can take a look at how the latest AI feature will work before the release. First, on the test editor screen, click the AI icon. And through the message window, send the prompt text to the MagicPot AI agent. So prompt is like this. Fill the form with the following information and confirm the reservation. I will check in at 2025, September 23rd, and stay for 3 nights, 2 guests. Need breakfast. My name is John Doe, and no confirmation is required. Then the AI is thinking about what to do. Scan the screen, and then test script that satisfies the user request will be generated like this. It is thinking and analyze screen and scan screen, and based on scan result, it generates test scripts like this. So you can see script is generated. Input date as instructed, and stay 3 nights, 2 guests, check breakfast checkbox, input name, and confirmation is no, and finally click confirm button. So this is how AI understands the UI screen and instruction or prompt, and based on them generate test script, no code script automatically. Like this is thinking way of generative AI. Actually, this test works correctly if you click run button. But unfortunately, our engineer somehow didn't run it while creating this demo video, and unfortunately, I can't show it today. In the coming 1 or 2 months, it will be shipped, and you will be able to try the feature on your machine. Okay, I will introduce another idea.
Iya.
Okay, thank you. Another idea is improving the calculation of the locator to identify the UI element with generative AI. For example, if the test target page has a link inbox 8, 8 represents the number of unread emails, and MagicPot tries to generate an appropriate locator to locate and manipulate this element. Maybe it will be something like the link labeled inbox 8. But when we run this test script, the number of unread email could be changed to 7 or 6, and then the test run will fail because it cannot find the element with the text inbox 8. This is the limitation of the logic-based locator calculation. Humans can easily say the number of unread emails should not be used for locators, and the locator should be just the link labeled inbox. But it is not easy for computers to distinguish robust text and dynamic text. Which part should be used for locator and which part shouldn't be used for locator. But if we use AI to generate locators, we expect the AI understand which part is suitable for locators and which part is dynamic and fragile. And it generates a good locator link label inbox. Such a flexible locator calculation could drastically reduce the number of unstable locators and reduce strange test failures. Also, we want to improve the capability of the self-healing feature by considering the context more deeply with AI. Self-healing of MagicPot can fix test failures caused by changes to the page design or structure. But it can only change the location of a locator of a step. In other words, it can't add new steps and can't modify or delete existing commands. Also, it can only do a simple fix and can't manage changes to the user operation flow on a UI. But by using generative AI, more flexible self-healing will be possible. For example, let's say the test target page has a create button to create a document. And we have the test script to create a new document by clicking the create button like this. If one day the UI is changed and the necessary user operation flow is updated, like clicking create button first, then choosing the document item from the menu. Then this test script cannot create a document anymore, because now it requires two steps. But if the generative AI self-healing happens, it understands the original intention of the user from the comment, create a new document, this comment, and recreate the new two-step commands. This generative AI self-healing will be more flexible and will make test cases more reliable and less fragile. I also have various ideas for generative AI features. For example, if a test fails, the AI agent repeats fixing it and rerunning it until the test finally passes. Or, if a UI change happens, the AI can judge whether the change is just a temporary one, like a one-time ad campaign pop-up, or a permanent change, and can decide whether it should ignore the pop-up or add a permanent fix to the test case. Another idea is generate Android tests from iOS tests. Currently, if Android and iOS app have different implementations, we need to prepare different test scripts. AI may reduce this burden. Also, if the product code is changed, the AI can check it and add necessary changes to the test code before the test run actually fails. By using the information of product code change, the AI can do a more advanced fix than normal self-healing that happens after a test failure. What are the possible outcome of these changes? I think the outcome will be drastic. First, currently a test script frequently doesn't behave as expected. This happens with any kind of test automation tool, and all users need to tackle these issues. But in the future, most of such trouble will be avoided or resolved by the AI, and every test will work as expected. Also, currently, the self-healing can fix small changes, but it cannot fix large changes. And if a page is largely updated, testers or developers need to fix the test script largely. In the future, the AI self-healing will resolve errors caused by such large UI changes, and the maintenance will be much easier. With these outcomes, test automation will become more and more easy to handle, and the scope of test automation will expand drastically. Next, I will discuss the future of software testing. This is the final topic of my presentation. 8 years ago, I had a chance to make a presentation at a big software testing conference in Japan. In the presentation, I talked about the final goal of MagicBot. At that time, the goal was that the AI understands the test case written in natural language for humans and run the test automatically. In this Japanese slide, this slide is used for the presentation. The AI reads the Japanese text, log in with user@example.com/path/path01, and AI understands it, and then input user@example.com to mail address area and input path 01 to password area, and then click the login button. 8 years ago, we had no generative AI at all, and no one could imagine AI could be so flexible and intelligent. So I expected it would require 20 or 30 years, even if it could be realized by AI in some way in the future. But just after 8 years, I believe simple test cases of such test case generation will be realized in the next couple of months. And the final goal I imagined will be finally realized within 10 years. So within 10 years from my presentation 10 years ago, 8 years ago. So the speed of progress of AI is actually accelerated more than we expected 8 years ago. So recently, I'm seriously thinking about the future of our business and product. And that is the same as the thought about the future of software testing. At the end of my presentation, I will share some of my thoughts about the future. The first thought and question is the full test automation with just a natural language possible? I think that is technically possible. But if we save test cases in natural language and run the test by a generative AI engine, it could cause some problems, such as high cost of generative AI, slow test execution due to computing timing of AI, unpredictability due to AI hallucination, and lack of trust due to black box of AI's mechanism. So I predict even if the AI becomes very intelligent, people will generate some test scripts independent of AI from the natural language test cases, and run test repeatedly by using the test script. And when UI changes break the test script, people will regenerate the test script from the original natural language test script. I think this will be the new standard of the test automation in the AI era. Then, what kind of test script could be used? I think there are 3 possible patterns. The first pattern is that a test script is in code style, like Selenium. And when editing the test, users edit or execute the test script. And the second pattern is that a test script is in code style, like in no code style, like MagicBot. And users edit or execute the no code script. The last pattern is a bit unusual. From the human instruction, a test automation tool generates test script in the clear natural language. And from it, the tool also generates a code script. When editing the test script, users edit the clear natural language script. And then the code script is automatically updated. When running the test, the code-based script is executed. This architecture allows the user to maintain test script as natural language. I'm not sure which pattern will be mainstream. I think each pattern has its advantage and disadvantages, and maybe 3 types of tools will coexist. And the next question is end-to-end test automation enough for all testing? I mean, if the creation and maintenance cost of end-to-end test drop, should we automate all test scenario as end-to-end tests? Honestly speaking, I have no answer now. Even if the creation and maintenance become easy, execution of end-to-end tests remains slow. And seemingly, we should keep using faster unit test and integration test as well. But if a company tests everything manually now, automated end-to-end tests will just completely replace them in the future. And they cover all types of testing. For such a company, full automation by end-to-end test will be a rational option. It is difficult for me to predict which style will be mainstream now. The next question is, can AI handle test design in addition to creating and executing test scripts? As far as I investigated, the planning and design of test requires more real-world and business knowledge, and their accuracy is lower than that of test automation script. MagicPot will focus on the creation of test automation scripts for the moment. But if users want to try the test design by AI, they can try that by passing source code, documentation, and the specification document to the generative AI and generate test cases. Once the test cases are generated, users can pass them to MagicPot's AI and generate a no-code test automation script. The next question is, will AI replace quality assurance job? Many developers and QAs are worried about that. At least, the generative AI and AI agent will accelerate the shift from manual testing to automated testing. I don't think AI will replace QAs completely in the near future, but it will have some impact on entry-level QAs or testers. Because people say job opportunities or entry-level developers may be reduced, and QA jobs may have the same impact. To find a good job, it will be more and more important to have skills in the test design, exploratory testing, and using AI to advance automation. It is not easy for AI to replace them, and they will remain essential even in the AI era. So finally, I will ask this question. Will AI make no-code test automation tool unnecessary? As a CEO of an AI test automation tool company, I need to think about this question deeply. So fortunately, I believe no-code test tools won't be unnecessary. AI or recorders can generate a test code script, but for non-engineers, it is difficult to understand or modify the code test script. And it is kind of a black box. But if the generated test script is a no-code script, non-engineers can understand and adjust the script easily, and can avoid the black box problem. So I think no code will keep its own unique value. It won't be unnecessary. MagicPot role is to empower all QA professionals to use AI as a powerful tool. So to achieve that, we want to keep the test automation easier, more powerful, and more sophisticated with the power of generative AI. So thank you for listening to my long presentation. That's all for me. Thank you. So maybe I already received several questions. Let me check the chat. No.
Okay, thank you very much, Mr. Ito, for such an insightful and inspiring presentation. Now we're gonna go to the Q&A session. We already have some question as of right now. Maybe I'm gonna read the first question from the chat. It's from Ahmad Arwan, who is a lecturer actually at University of Brawijaya. The question is, very cool products and presentation. The main problem in test is creating test case, how to using AI to understand the logic and create test case.
Okay, thank you. Let me check the chat again. The main problem in test is creating. The main problem in test is creating test. The main problem in test is create how to using AI understand the logic and create test case. Okay, it's good. Okay, so actually I'm not sure how generative AI internally understand it. So generative AI is actually very intelligent. So based on this human prompt, first maybe AI understand they need to understand the current UI screen. So ask MagicPot to take screenshot of page and then MagicPot send UI screenshot and HTML to AI. And then generative AI analyze HTML and try to understand which item to manipulate. So, and AI already understand the MagicPot command. If the AI wants to click the item, their AI should call click command of MagicPot. If they want to input text, AI already know input command of MagicPot works. So, like generating source code by using MagicPot command, generative AI generate test scripts. So this is very similar to source code generation or unit test code generation by generative AI. As generative AI understand MagicPot command and UI, it can generate test script automatically. So, so this is, I think, how generative AI code generation works. Okay. This is my answer. And maybe.
Okay, thank you, Mr. Nozomi. So by generating the source code, we can analyze the test case for each case, yes. And also there's a next question on the chat. How does MagicPot see the role of QA engineers in the future with advent of no-code testing platforms? Will scripting skill be needed?
Okay, so maybe in Japan, many QAs don't have a coding skill, but some has coding skill. So QA with coding skill still prefer code-based script, so like Selenium or Playwright. And QAs without coding skill prefers no-code tools like MagicPot. So currently they coexist. It depends on company's preference. So I guess the situation will continue. So maybe if you have a scripting skill, so we can do more high-level things by using code-based Selenium test automation tools and generative AI. Mm. So you can use some coding agent like Klein or Devin or ChatGPT. But even if you don't have a scripting skill, you can do lots of things by using no-code tools and its AI assistant. So maybe difference between code users and no-code user became small. But maybe mm, maybe in some situation, no-code still cannot cover everything. So actually, in the future, currently we are no-code platform, but in the future, we want to support code style script and mm, then code style script and no code style script can be exchangeable. So in such situation, MagicPot will become both code and no code platform. And so so each user can collaborate and so discussion with which is best, uh, code or no code may be meaningless because MagicPot supports everything. So this is my future prospect.
Okay, so allow me to translate, yes.
Yeah.
So, yang dimaksud sama beliau, jadi di masa depan, mungkin terutama di Jepang, untuk beberapa tester ada yang punya skill coding dan ada juga yang belum punya skill coding. Jadi kemungkinan kedepannya mungkin tester bakal bisa berdampingan. Orang-orang yang belum punya banyak skill coding bisa menggunakan low code based automation testing, dan orang-orang dengan skill coding juga bisa menggunakan code base seperti Selenium. So people can have choices like low code based automation and high code based automation like Selenium, right, in the future, right? And there's also a question from the participant, Muhammad Asti Seta. You may unmute yourself.
Okay. First of all, thank you for such wonderful material. There are some questions actually. May I ask several questions about the materials? Okay. So first of all, I see that there is some limitation of the MagicPot's AI, especially in the UI chains. What I'm curious about is how to what extent the MagicPot AI can understand the UI chains in the application. Like, does it account for the color change or perhaps image change? And is there any other limitation to the current technology, especially for the fast-growing application frameworks? That, for example, in the mobile application frameworks, we have like React Native, Kotlin multi-platform, KMP, Kotlin multi-platform, and even Compose and Flutter frameworks. And does it already account for that? And what is the plan, or how does the MagicPot handles the future growing application framework? And the second question I want to ask is, as I see from the presentation, I see that the end-to-end testing is still remains slow, and unit test and integration tests will likely to still be important. And from the early slides, I see that there's still no automation testing for the UI and integration test. Do you think we can get down into the unit testing level with this technology? And the third question, I don't know. I think it's a little bit out of topic, but I want to ask: do you think it is possible to us to test the AI itself? To think about it, the AI is some kind of software itself. So, is there any framework, or do you think we can test we can automate or even automate the AI testing? I think that's all for me. Thank you.
Yeah, thank you. And then first, let me answer the first question. So, a limitation of MagicPod. So, as for mobile app testing, so MagicPod can test most of applications, Swift iOS application, Kotlin or Java Android application. Also, we support Flutter and Jetpack Composed. One limitation is Unity. So Unity is widely used to create game applications, but Unity does not expose internal UI structure to test automation tools. So currently, it is difficult to manipulate. MagicPot, MagicPot understand test target application through UI3 or HTML, so rather than image. So if there is no UI information provided by application, it is difficult to manipulate. So, and the second question is maybe your question is if how we should test AI or so, so if application becomes more and more AI, maybe testing of AI is not so easy because result may change every time. So maybe we should separate AI model and non-AI part. So and when you test UI screen or web screen, maybe we should fix the result of AI always the same. Then we can get a stable answer. Without AI's hallucination. And as for testing of AI, actually, I don't know how people test it, but so maybe they AI AI company test them maybe based on statistic based approach rather than unit test for each case. They check, maybe they have expected input and expected result pair, and they measure percentage of correct answer. And if percentage increased, maybe model get better. And if percentage decreased, maybe model get worse. So by using such a probability-based approach, I think people test AI. So maybe in some day AI can test test and measure such output. So currently, for MagicPot, users need to still add a check command by themselves. Assert this element is something like this. So test script still can do this, only instructed by user. But in the future, maybe if we run end-to-end test while running test cases, AI monitor each pages, and if something is broken, AI point out, even if human don't say. For example, this layout is strange, or you input this value in the first screen, but in the second screen, different value is displayed. So maybe after creating the test generative AI engine, test creation engine, maybe we will work on this kind of AI bug detection feature. So this is my answer.
Oke, thank you, Mr. Ito. Gimana Kak Muhammad Asih, apakah sudah terjawab?
I think that's such a wonderful question, and it's intriguing to me to seek the opportunity about this future of this technology.
Thank you.
Okay, for the next question is from A.N. Ahmad Yoga Wilanda. So the question is, beyond just finding bugs, how does MagicPod fundamentally change how development teams think about and approach quality assurance for their mobile application?
Okay, this is good question. So maybe without automation, development team always think change of source code is very risky and every change need to be done very carefully. But if people have a test automation tool, they can they can try to change everything without fear. So before test automation, people think if we had this, if we add this change, we need a 1 week test. So this is difficult to do now. But if we have test automation, we can we can easily add any change very easily anytime because test finishes just by clicking button. So this changes the thinking way of development team. So test won't become obstacle of change and velocity can be very accelerated. Without test automation, due to test burden, daily release is very difficult. But if we have so many tests, you can release new changes every day. So with test automation tool, people think uh, people think test is not the obstacle of release so anymore, and they can challenge aggressive or proactive refactoring very casually. So and then development become very comfortable. So I 10 years ago, I worked at a company without test automation. It was very uncomfortable experience, very frustrating. Manual work is very tedious, so actually I didn't like development so much. But after started using test automation tool, development became very comfortable, and so I I I became to prefer I became to love development again. So I think test automation and MagicPot will give very good user experience to developers. So that is my answer.
Okay, wonderful answer, Mr. Nozomi. Shall we continue?
Yeah. Okay.
So on the next one, we have Rian Adi
Rian Adi
Saputra and
Saputra and
Zidan Arfi. Thank you for the previous explanation, but I have a question for it. So he have a mobile app that he just developed and want to try testing it using MagicBot, but haven't published the mobile app to public yet. Can he still test it? And can you show him how to set up the mobile app? Thank you. And also, in the scale from 1 to 10, how hard is learning the curve in mastering no code by using MagicPod? Maybe sometimes automation makes us frustrated when the result is not as what we expected.
Okay, thank you. And let me answer first question. So maybe I can demonstrate how MagicPot works. So, especially if your application is not public, how to test it. So it is actually easy. Let me share my screen again. So, sorry, it contains some Japanese. So if you want to test an application, mobile application, the process is like this. First, you specify application file. So mobile application has internally APK file format. By uploading APK file, you can launch your own device on the cloud device. So even if it is not published, you can use it. Also, so and if you so sometimes some people test the internal application. So even if mobile app access to internal web server, if you allow access from MagicPot still can access to it. Or MagicPot also have support local testing feature. If your server is not public or available on cloud and it is not public, you can still install MagicPot desktop to your PC, connect your physical device by USB, and run it on your local environment. So, release, so application before the release still can be tested. And okay, so and next question is from Zidane. In the scale from 1 to 0, from 1 to 10, how hard is it running curve in mastering the no code by using MagicPot? Because sometimes automation makes us frustrated when the result is not as what we expected. Okay, the question is learning curve of MagicPot. Actually, people say in the first several days, people can learn how to use MagicPot. This is very easy. They say just launch app, click scan button, and choose element and run. So if you just want to do simple test cases, like click button, input element, and check result, it is very easy. You can learn how to use it just in 1 or 2 days. But if you want to use more expert features like sharing script between different test cases, or data-driven test, or conditional branch, if statement, or for loop, it requires more time, additional 1 or 2 days. But when you don't need to learn everything in the first week, when you can just start creating test cases, and when you find some problem and you want to do something, you can just search and search the solution and use a command. So if you learn software programming, I think you don't understand every library in the first day. You maybe only just learn how to write a basic program and start writing program. And after you facing some problem, you find a library. So use of no-code test automation tool is similar. You can start creating test case in the first 2 or 3 days and 1 or 2 days. And if you face some difficulty, you can search help pages, or you can even send questions to MagicPot support team. So maybe we have support team, and this is a unique difference from open source test automation tool. So this is maybe more helpful for users without deep knowledge of test automation.
Okay, thank you. Maybe we can go to the next question. Yes, Mr. Ito. So the next question is from Muhammad Rizki. I'm experiencing extremely slow scrolling when running test cases in MagicPod, especially on pages with long content. What could be causing this, and how can I optimize it? Does MagicPod support features like lazy loading or smart scrolling to improve performance?
Oh, sorry for trouble. I see. Actually, especially on mobile device, people say scroll scroll is very slow. So MagicPot has a scroll command, and it has several options, slow and fast. Okay, let me show the screen again. So MagicPot has scroll, swipe command, and it has option. By default, it is slow, scroll speed slow. But you can choose medium or fast. If you choose fast scroll speed, scroll become very faster. But instead, scroll amount can be different each time you scroll. So this is not stable. But if you don't mind unstable scroll, this is fast and random scroll is enough. And if you choose slow, it is slow, but scroll amount is always the same. So you can use two types of scroll depending on your purpose. And also, currently, iOS testing is especially slow, but we are now working on improvement. Maybe within 1 or 2 months, performance of scroll and everything on iOS device will be improved drastically. So if you try it after this large improvement, you can see more comfortable scroll experience.
Okay, so the next question is from Farid. Does MagicPod use AI in its no-code testing platform? I'm curious how MagicPod handle the issue of AI bias. It seems like a really important challenge as AI plays a bigger role in automation tasks.
Okay, thank you. Yes, we actually internally use this generative AI. So, and it sometimes returns wrong result or biased answer. Maybe actually, as for wrong result, maybe it is difficult to completely avoid it. So if test case generated by AI is wrong, users need to check it before running it and fix it by manually. But once test is generated, this test run does not use AI unless as long as it works successfully. So it does not have any bias or hallucination problem. And if test fails, self-healing by AI happens, and actually AI is not perfect and sometimes propose strange self-healing result. AI says this test failure should be fixed like this, but sometimes it is wrong, unfortunately. So to mitigate this situation, after change, MagicPot continue testing, and if test does not work as expected, finally, Magic Pot judges this change by AI's mistake and revert this change. And even if this AI change work correctly, Magic Pot does not accept this change automatically. After running every test, MagicPot asks users, AI changes this screen like this and test passed. But is it okay to accept this answer? And the user can check AI's change before accepting it. So if it is no problem, user accept it. So for every AI changes, maintenance by AI or test creation by AI, users have the chance to review it. And users can avoid biased or wrong answers. So this is how MagicBot avoid AI's problem. Okay.
That's right. Okay, thank you for the answers.
Mm.
And I think this is our last question from the chat.
Yeah.
So Alien Akbar is wondering, how does AI change the traditional paradigm of test automation compared to conventional approach?
Okay. Currently, automated test is used all over the world, but still manual test is very important, and manual test is mainstream task. People think manual. People think most of tests are manually done, and they try to automate some of tests. But in the AI era, more and more tests can be automated by thanks to AI's feasibility. And maybe in the future, automated test will be the first option for people. People first think about or most of tests can be automated by AI, and they think, but only if test automation by AI doesn't work as expected, they try manual approach. Maybe problem could be because it's need to interact with some physical thing like face scan or IoT devices. For such cases, AI test automation may not work. So, but maybe more and more AI automation-based approach will be more and more first option, and manual test will be second option. So this paradigm change will happen. So so maybe for everyone, skill of automation test is more and more important. So, but of course, code test automation by code is not everything. So no code is always option. So either is okay, but test automation will be very important, more and more important skill. So in someday, maybe AI can do everything. So AI can write every program, and it does not have any bug. And all desk work or PC work can be replaced by AI. I don't know when this day comes. 3 years later, 10 years later, 20 years later. In such days, unfortunately, maybe test work of testing will disappear, but luckily, all white collar work will also disappear. So it's difficult to think about this kind of future. But near future, automation will be more important. Yeah.
Okay, Mr. Nozomi, that was quite wonderful discussion about AI and the future of automated testing.
Yeah.
Thank you for coming to our online forum.
Yeah.
We really enjoyed the discussion.
Yeah, me too. It was very delightful time to me. It was great experience. Thank you.
Yeah, and now sadly we have now reached the end of our session. But before we officially close the session, let's capture this moment together.
Sure. Okay.
And we kindly ask all participants to turn on your camera and give your best smile for the documentation. And also our PDD creative team will lead the photo session. Please, Ranger, the session is yours.
Maybe we gonna capture the screenshot first on the first screen. So you guys, if you're on the first screen, please
Yeah, SS.
bring your best smile. Okay, on the count to 3. I remind again for everyone to please turn on your camera. We're gonna do screenshot of this session. So for the guys that on the first screen, on the count of 3. You guys ready? 1, 2, 3. Okay, thank you. Now to the next slide. On the count of 3, guys. 1, 2, 3. Okay, the third slide. On the count of 3, guys. 1, 2, 3. Okay, we have 5 slides, and now we're on the 4th slide. On the count of 3. 1, 2, 3. And now on the last slide, guys, it's the last. Bring your best smile. Show your teeth. On the count of 3. 1, 2, 3. Oke, thank you guys. Terima kasih kepada seluruh peserta, narasumber, serta panitia atas partisipasi dan kerjasamanya dalam menyukseskan acara hari ini.
Thank you,
We hope
Nos.
today's session bring you insight and inspiration.
We
for
hope today's
everyone.
session bring you insight
Stay
and
motivated
inspiration.
to learn, innovate, and
Stay
create.
motivated to learn, innovate, and create.
And for the absent or registration absent for the attendee, you guys could scan the QR code that could be shown by the operator team, or you guys could submit on Google Form by link on the chat room.
Yes, Miss Annie, can you on? Okay, yeah. This is the
Sorry.
last session for Nozomi for
Yeah.
the
Thank you, Nozomi, for your contribute in our guest lecture today.
Thank you.
Maybe in another time you will come to Surabaya to meet our student for offline class. Thank you so much, Nozomi and Suzu.
Thank you.
yes, thank you so much. Maybe you can join in WhatsApp, yeah. It is the last session.
Yes.
Okay, thank you.
Thank you, Nozomi.
Yes.
Okay, thank you.
Thank you so much, Mr. Nozomi.
Thank you so much.
Ya, reminder sekali lagi untuk teman-teman yang belum melakukan absensi bisa mengisi form yang berada di link chat Zoom. Oke teman-teman, karena acara ini sudah berakhir, terima kasih atas partisipasi dan kehadirannya. Dan ini kita ada suatu kejutan ya teman-teman, karena pada hari Rabu kita ada lagi nih sebuah guest lecture atau kuliah tamu yang teman-teman bisa hadiri. Untuk acaranya sendiri bersifat online, jadi teman-teman bisa stay up to date di IG-nya sa.telkom University Surabaya. Terima kasih atas hari ini teman-teman. See you next time.
Terima kasih Esa, Alif, Bu Dewi, makasih.
Come on now, follow my lead. I may be crazy, don't mind me. Say, boy, let's not talk too much. Grab on my waist and put that body on me. Come on now, follow my lead. Come on now, follow my lead. I'm in love with the shape of you. We push and pull like a magnet do. Although my heart is falling too. I'm in love with your body. Last night you were in my room. And now my bedsheets smell like you. Every day discovering something brand new. Well, I'm in love with your body. 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 Every day discovering something brand new. I'm in love with the shape of you. When we came, we let the story begin. We're going out on our first date. You and me are thrifty, so go all you can eat. Fill up your bag and I fill up the plate. We talk for hours and hours about the sweet and the sour and how your family's doing okay. And leaving, getting a taxi, kissing the backseat, tell the driver make the radio play. And I'm singing like, girl, you know I want your love. Your love was handmade for somebody like me. Come on now, follow my lead. I may be crazy, don't mind me. Say, boy, let's not talk too much. Grab on my waist and put that body on me. Come on now, follow my lead. Come on now, follow my lead. I'm in love with the shape of you. We push and pull like a magnet do. Although my heart is falling too. I'm in love with your body. Last night you were in my room. And now my bedsheets smell like you. Every day discovering something brand new. Well, I'm in love with your body. 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 Every day discovering something brand new. I'm in love with the shape of you. Come on, be my baby, come on. 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 I'm in love with the shape of you. We push and pull like a magnet do. Although my heart is falling too. I'm in love with your body. Last night you were in my room. Now my bedsheets smell like you. Every day discovering something brand new. I'm in love with your body. Come on, be my baby. Come on, come on, be I'm in love with your body. Come on, be my baby. Come on, come on, be I'm in love with your body. Come on, be my baby. Come on, be I'm in love with your body. Every day discovering something brand new. I'm in love with the shape of you.